In this video, I'll be demonstrating how I executed an Arp spoofing attack on a simulated network scenario. The very first step was reconnaissance. I used reconnaissance techniques to identify the IP addresses of my targets in my local lab by analyzing network traffic and Arp tables. Tools like Arp Scan or Nmap allowed me to probe the local network, mapping out active devices and their corresponding IP and MAC addresses. By examining this information, I pinpointed the target machines. The IoT devices I'll hack today are 192.168.0.115 and 192.168.0.110. Let's go over my ARP spoofing code. My script is designed to send false ARP responses, effectively poisoning the ARP cache of two devices. I begin by targeting a specific IP address, the target IP, which I assign to the victim machine, and a second target, which represents the gateway. So my attack works by convincing each device that my machine's MAC address is associated with the other's IP address. First, I craft ARP spoofing packets with Scapy using the ARP class. For the victim, I impersonate the gateway by sending an ARP reply, which is opcode 2, with my MAC address, right, the attacker's MAC address, but saying that the source is the gateway. Then I reverse roles for the gateway, claiming that I'm the victim. So I put in my MAC address, but the IP is the target's IP. This tricks both machines into thinking my machine is a legitimate intermediary for their communication. My code is pretty flexible because it can take in inputs for who is the attacker, who is the target, and who is the gateway. And my main loop will repeatedly send these ARP spoofing packets every second, ensuring the ARP tables on the devices remain poisoned. So in essence, this showcases a real-world man-in-the-middle attack where ARP's lack of authentication allows traffic interception.
What you'll see next is me use my network in real life. I've got my controller imp on the very right on that breadboard, and on my computer is the minion device, and the LED's been toggled on and off. You can see that when you try to intercept that traffic, so you can see the attacker's Wireshark window in Kali Linux on the very right of my screen, and the controller device's web page on the very left of the screen. Even though the toggle LED command is being pressed over and over, the Wireshark doesn't intercept any traffic.
In order to enable packet forwarding or to allow commands from the controller imp to go to the Kali machine and then go directly through to the minion imp, and allow packets from the minion imp to go directly through the attacking machine over to the controller imp, you have to enable IP forwarding. And in order to do that, just use system control, as you can see right here. Okay, so if you run the ARP spoofing code, it'll ask you for the target's IP address. And previously, in reconnaissance, we found that that is 192.168.0.115 for the controller. The attacker, our MAC address, has been found to be ending in F3D5, so that's totally fine. And then the second target's IP address is 192.168.0.110. So that's the minion imp. And so this is the Wireshark filter that we would use, right? So we're looking for traffic going from the controller to the minion and from the minion to the controller. So the ARP spoofing attack is running right now, as you can see. And now let's see if we're able to spy in on any connections or any packets being sent from the controller to the minion imp. And as you can see, we just saw a bunch of packets or a bunch of traffic being forwarded into our computer first, or the attacker computer first, before it gets over to the controller imp. Now, when we look through, we are able to notice that the controller .115 is sending over to .110, the minion, a UDP packet using ports 1, 2, 3, 4, or using port number 1, 2, 3, 4, and it is sending with a payload of LED, just in plain text, LED. So that gives us the idea that if we, as the attacker, want to control this LED light, we need to send a UDP packet to the minion imp, which is at .110, to the port 1, 2, 3, 4, and it has to be a UDP packet with the payload LED. So let's go ahead and try doing that. So let's run this command. And as you can see, we're able to toggle the LED on and off by using the attacker's computer instead of the controller imp, or the controller imp's webpage.
Here we go. And you're able to see that you can use the Kali machine, the attacking machine, in order to control the LED light.
I propose a more secure network topology where every device connects to the router. So that way a man-in-the-middle attack can never be formed because at least one of the two devices in a connection is secure. So the link between them can't really be hacked or broken. However, the disadvantage is that it now takes longer for packets to travel from the controller to the minion. It used to be just one hop, but now that packet has got to travel through the entire internet. However, this is a neat solution using network topology.